All right. What I want to talk about now is the other important theorem when it comes to integration. We talked about U substitution, or the substitution rule, as sort of the reverse of the chain rule. Now I want to talk about integration by parts as the reverse of the other essential rule for differentiation, which is the product rule, right? So remember, we have the product rule here, which says that the derivative of a product is f prime of x, g of x, plus f of x, g prime of x. Right? Now, when we're looking at this here, what we want to do is we want to undo the product rule here. So we want to integrate both sides of this. Right? So if we integrate this thing, right, so we got to integrate this whole right side here, f prime of x, g of x, plus f of x, g prime of x, dx. Okay? Now, this is going to look a little maybe underwhelming at first, but what we're going to do over here is we're going to integrate this side. So this just becomes f of x, g of x, and then I'm going to write the plus c here. Right? Now on this side, all I'm going to do is split up this integral into two pieces. So f prime of x, g of x, dx, plus integral, f of x, sorry, I didn't mean to change colors there, f of x, g prime of x, dx. Right? And then what I'm going to do is I'm going to take this piece and move it over to this side, and I'm going to change the order of the equation. So it looks like I'm going to put the right side first this time. So f of x, g prime of x, dx. This is equal to f of x times g of x minus the integral of f prime of x, g of x, dx. Right? And actually what I'm going to do with this plus c is this integral right here. When I compute this integral, I'm going to get a plus c from that. So I'm just going to hide this plus c right here. I'm going to hide it inside of that integral. Right? Because again, we're going to get a plus c once we perform that integral, so we'll deal with that when it shows up there. So this right here, this is what we call integration by parts. All right. So what is the name of this? Well, what we're sort of doing is we're kind of integrating these two functions separately in some sense. Right, like here, we integrate the g here, and that gives us this term, but then now we get this new integral where we, in some sense, have to integrate the f. Right? What I think is a good way to interpret how integration by parts is working is what it essentially lets you do is take this derivative right here that's on the g and move it over to f, right? And you can see it's on the f here. All right. Let me go ahead and erase that because that won't look good in the final notes there. But that's in some sense what integration by parts is doing. It's allowing you to move the derivative from one function to the other. And then you pay this price here of this f times g term, and you get a negative, right? Now, this theorem, though, this integration by parts, this turns out to be one of the most essential results from calculus. There's an entire field of math called partial differential equations, or really differential equations in general. It uses this property over and over and over, right? You usually do a trick where you take a function you'd really like to integrate, but it's like the derivative of something. So you multiply it by a function that can take all kinds of derivatives, and you start using integration by parts to move the derivatives over. it's kind of a neat trick. And there's lots and lots and lots of other ways that integration by parts is used in later mathematics that I won't attempt to go on about here, but let me just really kind of emphasize here. This is one of the most essential results in calculus. Right? So we're not going to quite use it to that high of a level here, right? We're just going to, do some basic computations with it and try and get a conceptual idea of it. But yeah, it's a really wonderful theorem. Right? To finish up here, let me say, how would we do this with bounds for definite integrals? So let me say for definite integrals, right? It looks pretty similar. So if we integrate here from a to b, f of x g prime of x dx, right? So we have our f of x times g of x minus integral from a to b, f prime of x g of x dx. And then what happens with this term here is this term's kind of already been integrated. So we just evaluate it from a to b. So it's sort of like that, after the fundamental theorem of calculus part, right? So yeah, so that's integration by parts. Hopefully seems pretty interesting and useful. Like I said, this will allow us to integrate many, many things that we wouldn't otherwise be able to.